Taxonomies, ontologies, and knowledge graphs. I think at the moment, nearly everyone is talking about them, but nearly no one knows how to build them. But before we look into that, what are they good for in search? So imagine we have a large corpus of academic papers. When a user searches for machine learning in healthcare, the system or the taxonomy could be used to recognize machine learning as a subcategory of artificial intelligence. But we could also use it to narrow down. So basically, we could take the term healthcare and identify that it has subfields in diagnostics and patient care. And we can use all the things, the additional categories or fields we have identified to expand the query or narrow it down. And we then can return results that include papers, so for example, on neural networks for medical imaging or predictive analytics and patient outcomes, something that wasn't really in the query or not even closely related, but can have good results. We can also use it to filter down and remove papers. So, for example, we have our category of artificial intelligence, and we remove any paper that is not tagged appropriately, because they might just mention the term artificial intelligence in a side note, but isn't really a paper on the topic. So we are basically building the plumbing, the necessary infrastructure for tagging, categorization, query expansion, and relaxation, but also filtering. So how can we build them? And that's what we will be diving into today in this episode of How AI is Built. Today we have Jessica Talisman with us, who's working as an information architect at Adobe. And in my opinion, she's the expert on taxonomies and ontologies. Let's do it. Especially the starting point for me is the most daunting. Is glaring at a blank page and you have a dooming amount of documents in front of you. I have no clue how to start in most cases.
The way that I'm sequencing it is metadata, and then taxonomy. So flat list to taxonomy, taxonomy to ontologies, schema, design. And then from ontology to knowledge graph. Oh, I'm sorry, I skipped thesaurus. Thesaurus to schema to ontologies.
What's the metadata you would actually start with to set yourself up the best for building all the stuff down the road?
The metadata that you would, if you think of it as tags that enter a system, if you're tagging content or tagging resources, if we call it resources or assets, you start with those flat lists. And so designing for it can happen in a number of different ways where you can extract using vector databases or using vectors to determine those groupings and nomenclature. You can also scrape. So there's different approaches. You can also use internal stakeholders and have a metadata request or tag request, or you can take existing labels within a system and use that as your starting point for flat lists. So I usually do document extraction. And then the taxonomy process, the bridge from metadata to taxonomy happens when you have to curate and disambiguate and structure it as a hierarchy.
Yeah. How is the interplay? Because in the end, the amount of text I could use again are endless.
Yeah. And it can be domain specific. For example, if I'm going to look, like another great starting point for determining metadata, if you know what your end result, if you can predict your end result, and your use cases. For example, if I'm building a system where it's necessary because of B2B business to align with the outside world, we call it outer world assumptions, then I'm going to want to reconcile across openly available taxonomies. That would be Google's product taxonomy, GS1, IAB, government taxonomies, and then use that as the starting point. I have a very interesting exercise that I suggest with people of trying to determine what your starting point is. I will audit the taxonomies and determine what is the same and what is unique or different. It's a pretty exhaustive process, but if you start to gain clarity in the application of these industry-wide taxonomies and then start to apply that, what's valuable and what is not, what aligns and what does not align with your internal project or modeling, then it helps you leverage what already exists as industry taxonomies, those labels and the structure, while also inserting unique domain where filling in the gaps. So that's the second part. You do an audit across all the industry-wide taxonomies. You can scrape or do clustering from your internal vocabularies and documentation. And then you can fill in the gaps of that taxonomy, what's not represented. For example, Google taxonomy is for ad tech and for e-commerce. So that's the use case for that taxonomy. Are you going to maybe, if you're not in a domain that's specific to e-commerce or ad tech, can you still use Google product taxonomy? Sure. But you need to model it and retrofit it to apply to whatever the specific domain or use cases are in your environment. And those are called coverage models. So building a coverage model means that you're curating and designing and building specific to the use cases and needs of your environment or your end result, your projected end result, what you want to accomplish or achieve.
Yeah. And maybe to pick up on the clustering part, because that's something that excites me as well, because we can bring AI into the process as well. How would you actually approach it? So you're assuming you have a lot of documents, you vectorizes in some way, whether that's TF-IDF or whether it's actually an embedding. And how do you actually go from like the clusters to the actual tag of the clusters?
Ooh, that's interesting. I use a tool for this just for low fidelity and easy interoperability and modeling called OpenRefine. I don't know if you've used that tool, but it's a decent product. We use that as a starting point and you cluster from within OpenRefine. You can download the JSON clusters from that exercise. There are 8 different algorithms, clustering algorithms within OpenRefine. So that just opens up the possibilities without having to be constrained to like a black box type system and being able to quickly pivot and shape and determine which cluster, which type of algorithm will work best on the data. That was it going to be Markov? Is it going to be nearest neighbor? And determining what shape does the data, what do the clusters look like? What's the proximity that you're looking for? Now, commonly, if we're going to bridge between clusters, how you apply clusters or how you use clustering to build your initial taxonomy, is that you're looking for groupings where you can obviously model a parent-child relationship, so broad to narrow. So you're looking for those inferences or those insights from your clustering. From there, then not all the labels that you've achieved through clustering can be applied in a taxonomy because there's rule bases in a taxonomy. You cannot create recursive loops. So synonyms and such and antonyms are captured not as first class citizens, but as alt labels or aliases to whatever the main label is that you choose. It really depends. So for the clusters, it depends on the starting data set, what you're working with, your material, the clay that you're molding. It really is like molding clay. And being able to determine how the data is behaving with those, whether it be vectors, embeddings, clustering, whatever you're using, TF, IDF, totally fair. But as you know, the algorithm that you choose will behave differently on depending on the data sets that you're starting with or the documents that you're starting with. How
So
robust?
basically,
Yeah.
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 So basically, you try to find or look at the shape of the data first by actually doing some form of visualization, and then basically figure out, okay, how is the data structured? Is it rather like you have clear clusters, or you have like
Right.
more of a fuzzy type of relationships?
Fuzzy, exactly. And fuzzy is not ideal. And so that's where it's important to play with lots of different clustering algorithms, because my one concern with vectors is that you're going normally, unless you build your own clustering environments or vector environments, you are going with whatever comes out of the box. Oftentimes you don't get to select. But oftentimes you can dial in according to TF, IDF, time, frequency, and accuracy.
Yeah. And have you ever tried using Node2Vec as well? Actually
Note,
using the,
yes.
yeah.
And I find that when you do that, your data, you have to have a starting structure or taxonomy. It doesn't do well trying to pick up or determine like the node to vec. And also this goes for text. There's some text-based text to SQL. You start looking at some of the complexities if you don't have a determined structure, like I'm dealing with a 3 or 4 level structure, and here's my framework. Oftentimes it doesn't work as well unless you have that starting point.
Yeah. And I think the challenging part why so many people actually get taxonomies wrong is like the rule set you mentioned.
Yes.
What are some of the other rules that actually exist for taxonomies that aren't so well known?
So I think one of them is that it's an ISO and it's actually turned into guidance over a strongly stated standard that's make it or break it. But I will tell that guidance is make it or break it. It has to do with information retrieval systems, and it has to do with what I call the basement of the internet, the big heavy hitters that are the search engines like Google and TikTok and whatever else do follow some of these rule bases. The ONSI Z39.19 is a standard for monolingual vocabularies and thesauri. And that is one of the main standards that you want to follow when designing taxonomy systems. And it declares the application of SCOS, which is simple knowledge ontology system, which is an upper ontology. So it's still an ontology, it's a schema, but it programmatically encodes a hierarchy, a taxonomy. And the rule base of that is a primary label or preferred label, which is your main label in the taxonomy. It cannot also be an alt label or an alias for other labels in the taxonomy. That is very important because that's where we create recursive loops or self-referential data. The other main point of that standard is disambiguation. We think it doesn't matter, but if you have a tag with no definitions or you have a taxonomy node with no definition, that's simply content, a system's going to have a very hard time making sense of a really global, ambiguous content that doesn't have context, doesn't have meaning, doesn't have context by surrounding it with children, so to speak, and parents. You have to have that modeling in there because although we don't realize it out of the gate, we think, oh, a taxonomy is just structuring tags or labels. That's the normal take on that. But in fact, it's your starting point towards knowledge graphs. That disambiguation and those definitions are absolutely essential. So if you think of your taxonomic structure or a hierarchy, if you add text definitions, imagine how much more richness you're introducing into your ecosystem, moving towards that context and meaning that we all seek to achieve with knowledge graphs and AI. So that's very important.
It reminds me so much of Joe Rice, to be honest, like all the data modeling, each column has an owner, each column has a definition, and each column can be traced back to the documents
Yes.
or to the source of the data.
And there has to be parity. So you always want to update and check your structure, your taxonomy, because as it grows, you still have to, and as you add to your taxonomy, you still have to continue to validate and make sure that you're not presenting ambiguity into the system. That's the whole point of modeling a taxonomy, is to start to remove that ambiguity for machines and people.
Yeah. And I like a big pet peeve of mine is actually trying to remove stuff first. Like whenever I'm starting a new implementation or a new project in an existing firm or an existing system, I first look at the stuff I can actually remove. How
Yeah.
often do you try to basically integrate like the removal loops where you actually look at the systems? Okay, how is my general taxonomy looking? What can be removed in like
I
the general workflow?
I do really encourage it's something that comes from library and information science that's called weeding. That's what we've always called it, where you move through a collection of any sort, including your databases, and you remove noise. Removing noise is the same thing throughout all systems and all domain practices. Really important to curate and care for your data set, your taxonomies. But then also another part of this is we also run into the problem when we weed too much of eliminating those signals that are essential. And what I mean by signals are those taxonomy nodes that not only disambiguate, but help to balance your data. And this is critical, is that you can have your closed, again, your closed world assumption, which is how you model your own internal domain. But you always want to keep your eyes or your vision set a little more broadly to pick up signals from the outer world. That could line up with competitors. It could line up with testing the temperature and like social interactions of industry related concepts that may not immediately touch your internal domain. Those signals are instrumental to helping to curate your taxonomy because we deal with industry trends all the time. And in order to pick up on those conversations, you don't know that those what you don't know. And what I mean by you don't know what you don't know is if you only keep your world so cloistered that you're only modeling what exists in your internal system, you're never prepared to catch on to or to pick up on those signals that are indicating that the market is shifting or the industry is changing or there's this new technology or there's this new concept.
Yeah. And you already mentioned scraping taxonomies. Is how does your process look like? Yeah, when you're going to the competitors, most won't have the taxonomies online. How do you actually try to get insight into how they are structuring their data and building their taxonomy?
I only go to taxonomy downloads, like
Yeah.
where the taxonomy is actually surfaced. So I would never go to a browse menu to determine a company's taxonomy because that's not necessarily their taxonomy. It's the display labels that you're seeing. And so we tend to enter this realm of confusion when we assume a taxonomy is a browse menu or a sitemap. Oftentimes, like those only represent what's required for indexing a site or simply for the UX UI. The real gold, and you can scrape for those types of labels within the code base, that's fine. But it again is very difficult to infer because most enterprises have redirects and backlinks and such like that, so just to make the site operate. So I tend to go to the actual downloads of those files, and it's just spreadsheets in those cases. And when you're looking at these spreadsheets, again, like I usually very quickly just go into OpenRefine to cluster and sort and determine like trends or any sort of signals as to the like how the data has been modeled to form a taxonomy because all labels, not all taxonomies that you find online are going to be validated and legitimate. That's just the truth. And so you have to do your own work. That's why it's dangerous to use openly available taxonomies. The other problem with openly available taxonomy is sure you can validate them in a system, but again, the use case, the original use case of that is always start from the use case. If it's a product taxonomy like Facebook's or Google's, those are for e-commerce and advertising and marketing. So they're going to have huge gaps in coverage. And you may not realize that those gaps exist. And so you want to compare it to if you have any internal, even if it's a flat list, determine again where those gaps are in that industry taxonomy. If you use, for example, the IAAB taxonomy, that's for marketing and content and advertising. If you use the IPTC, that's for media, advertising, marketing, news, that sort of thing. Understanding and actually doing your homework about what's the use case, what is the intended use or application of this taxonomy. And then starting from there and looking at and being very clear about what your use case is, then you're looking for gaps in coverage.
And You already mentioned the use case. Let's assume you already have created a taxonomy for a specific use case. How do you actually know that the taxonomy is working?
Ah, so usually that has to do with TF. So you want to measure relevancy, accuracy of those things. It depends on if your taxonomy, what the application of your taxonomy is for. For example, if you just have tags on content, you can obviously measure the performance of the content, whether it be from like an SEO's perspective, like that's sort of a rudimentary way to measure and to determine, like findability is a huge one, like how findable. You can do tests around that. Outside of the SEO use case, you're looking for things out of the gate like tag completeness. Have you achieved tag completeness on whatever the content or the data objects are? The other thing that is a dependency, though, and this is why that's a hard question to answer, is what is, if you think of the implementation of a taxonomy, it may be related to representing, for example, data objects in a database. So then that's why metadata and schemas are important. We're not even at ontologies yet, but we're looking at metadata and schemas. Does your database, does your data ecosystem have a data schema validation, registry and validation implemented to govern and to help to enforce the metadata that has been extracted? For example, you might have a schema that has required fields, and you may have topic tags that are derived from the taxonomy, and there's a requirement that you have to have at least one tag from the topics in your taxonomy, no more than 5, and that then the data objects exist, and that you can consistently say that the application of those taxonomy nodes within the database are complete. The thing about taxonomy is it's infrastructure, it's the plumbing, it's the pipes. And so oftentimes the way that you measure the success of a taxonomy is secondary. You're not necessarily going to achieve bold-faced results right out of the gate that are completely apparent. It has query times when you're looking, for example, across a data set and you're querying in a SQL database. How long does it take you to find results? Are those results accurate? Are they complete? You're looking for ambiguity. You're looking for issues with findability throughout a company data catalog. There's so many different levels. You can make connections or integrations with B2B customer data sets and databases more seamless. You can achieve higher customer satisfaction with your customers. So there's so many different ways you can slice and dice it. It's really hard to, without knowing the nuances of a system and again, the use cases, how to design those success metrics.
Yeah, and I think for me, the most challenging part, among others, is actually coming up with clear and intuitive labels. And in a
Yes.
taxonomy, this is like already a problem in classification cases. Especially nowadays, most people just use an LLM for classification, so the labels have
Yep.
even more importance. But the labels for the people who are actually doing the work of creating the training data have a massive impact on in taxonomies is actually like supercharged even more. How do you actually try to find the balance? Because the goal would be like a MISI label, like mutually exclusive but completely exhaustive. But that's never completely doable. So how do you actually approach that problem and decide what labels are the right ones, what synonym to actually pick as like the main label?
Yeah. So you want to use sources internally and externally to determine the right label. I usually go to large scale knowledge graphs like DBpedia, Wikidata, not Wikipedia, but Wikidata. You can access their ontologies and taxonomies pretty openly and publicly. And again, by determining what most people in the industry are using for those labels, and again, applying definitions. So that disambiguation process is critical. And then you can harvest from those open source knowledge graphs or taxonomies, you can harvest the preferred label by way of volume or consistency or parity between the systems. If everyone in the industry calls content docs, you might choose docs over content because that makes sense, because that's what the world calls it. However, you have to mitigate and negotiate between internal systems and external. The most important thing and your most critical role in shaping what those labels should be are definitions and disambiguating. So never have miscellaneous other, those sorts of labels. Miscellaneous and other, not well defined. It's a junk drawer. And so oftentimes you'll see those surface only because you're starting with a base data set. Maybe it's your own, where miscellaneous and other are used throughout. And so it comes back as a highly regarded necessary label. That's not necessarily the case. So eliminating ambiguity includes everything must have a defined label. Sure, you could say miscellaneous or other, or we haven't decided yet. Maybe that's your definition for it. Like, we're not sure. If you think about it from a practical standpoint, that should be your answer. Is if you're defaulting to those ambiguous labels, then maybe it shouldn't be in there. And the other part is that when you're pushed to be considerate and intentional about how you label things, the other thing is that an ambiguous label could be accessories. That's a great example from the e-commerce space. Accessory to what? So disambiguating things that do have actual constructive labels, but don't make sense as a standalone or without a definition. Are they clothing, like women's accessories, or how are you going to define or curate that further? And always think about it. If you went to a grocery store and you're looking to find something specific, I don't know, spices, you'd rely on those labels. So being as specific as you can and knowing that with those labels that you apply, you're helping someone navigate an environment, much like you do a grocery store or an online store. So determining what are the other things that this could be called, you can do by, again, scraping, or you can create algorithms or take an open refined knowledge graph approach to be able to, I don't know if you've seen, the reason why I like OpenRefine is there's an RDF plugin, which gets you closer towards graph, and there's schema reconciliation. So you can connect OpenRefine to these large open data sources, create a schema in there, and then reconcile it against the schema, and it will pull up all the results. And then you can actually gather the alt labels or synonyms from that exercise.
Yeah. And in the end, what part of the taxonomy is exposed to the user is very different. If you're picking up on the supermarket example, like for example, spices is a sensible level of granularity, but you could go even more fine-grained. How do you actually decide, like, where, at which level of abstraction do I start and end the taxonomy?
Oh, that's interesting. So one of the risks in taxonomy building is mixed granularity. That's like a pitfall in taxonomy design and building. Mixed granularity is when you have an extreme level of granularity at the bottom node or the leaf, but then other leaves are broader. So a machine tends to gravitate towards the most granular, which then makes it difficult to reconcile the broader. There, you end up with a very imbalanced data set that can be confusing to machines as far as what the tasks or jobs to be done. So I always err towards the first iteration is broad on purpose. Spices would be the lowest. I haven't gone into garlic powder or pepper or anything like that yet. I want to see how this behaves in the wild and where those gaps are, because it's much easier to add, to build upon, to scale than it is to take away. The reason why it's harder to take away is people, for the most part, are going to be the ones operationalizing ultimately those tags out there. And you'll have human behavior Some people will gravitate towards being super granular. Others will gravitate towards, it's fine, we'll just do the broadest possible, like grocery store, and just tag everything with grocery store or whatever it is. And so that's where it's easier to determine by volume and need and workflow, and then add the granularity as needed. Because the type of granularity you're looking for may actually be attribute dependent. You may be looking for spices by attributes. So your spices might be like spicy spices or whatever it is. That's more still global, but a little bit narrower. So really looking, because if your ultimate goal is to continue to scale and grow and possibly achieve like a thesaurus sort of NLP activated type of environment, or moving further into ontologies, the dependency is that primary modeling that you do with your list or metadata that then becomes your taxonomy. So those iterative approaches, all those design decisions feed into the later iterations and scaling of your information system.
Yeah. And I think, like, in my opinion, e-commerce companies should have the best taxonomies because they have the easiest, or they have it the easiest to link it back to search behavior and user behavior.
Yes. Yes. And something that's interesting is like commonly, and I don't think I've come across an e-commerce platform that doesn't activate like attribute value type, really entity attribute value models, because it's so attribute dependent. And marketing cycles and sales cycles and holiday cycles and seasonal cycles are so fast. That's like an instrumental part of how taxonomies are utilized and implemented. That would be a case where too much granularity gets you in trouble in the e-commerce example, because you're not going to have, for example, the attribute might be related to a season like summer, winter, fall, spring, or it may be relevant to like a holiday like Christmas or Hanukkah or whatever. You E-commerce companies tend to leverage at that point to get to that granularity.
Yeah. And I think, like, you have so many interesting tools like head, tail, and torso queries, which you can use to basically find what are the like top level tags, especially in the
Yep.
mind of the user, which is really interesting. How do you
Yeah.
actually differentiate the taxonomy of experts and the taxonomy of the end user? Is it
Uh,
sometimes necessary to build two different taxonomies, like a user-facing one or
oh,
an
yes.
internal
Yes.
one?
Yes, a display taxonomy would be what that's called. And so maintaining, and that's also useful because say that your customers include brand and marketing, like internally. You have some less technical stakeholders as well that request or require the display label for the sake of the customer to be just so, because branding and marketing require that. And so that negotiation between customers or the customer facing display labels or taxonomy is is necessary because it's important to have stability on the back end. Branding and marketing should not be deciding or determining what lives on the back end, nor should customers. Having the stability of those labels on the back end from a taxonomy perspective is really important. And then letting customers, branding and marketing decide on what those display labels are.
And then the two taxonomies are basically connected through some kind of map.
So you can map them with equivalency statements. So
Yeah.
using something like SCOSE or OWL, you can just simply use same as from an ontological perspective, and it draws parity between, or you can use crosswalking, which basically uses the same ontological or schema-based elements that draw parity between the two taxonomies.
What is actually, or what are the best taxonomies you've actually seen so far in the wild?
Some of them are a little bit outdated, and some of them, if I think of like Amazon's browse node, if you can find that, I think it's a pretty interesting taxonomy and throws a little wrench in the plan of Google and Facebook. It's an interesting alternative view. And so I appreciate Amazon's browse nodes a lot. That's a pretty solid structure. And I think some of the government taxonomies I'm partial to, like the EU taxonomy for jobs and employment and things like and domain expertise. I think that's a pretty interesting one. I haven't been completely wowed by any because, for example, once you get into certain taxonomies, there might be, they can be so vastly different. It's hard. It's like apples and oranges. They're not really, it's hard to draw equivalencies or the designs and the implementations like the GS1 taxonomies are relative to the BRIC schema and are very attribute heavy. So the construct of those taxonomies, and again, the use cases, the intended use case of those taxonomies can be so vastly different that it's hard to draw equivalencies and say, yeah, this one's the best. But I would say check out Amazon Browse Nodes. Secondary one, second to that would be the IPTC taxonomy. I appreciate that one. It's not perfect and there's some ambiguity, but it's pretty good.
Yeah. I'm wondering, when you're operating in like a tangential space, so for example, I want to create a taxonomy of industries. Can I also use a related taxonomy, so for example, of job types, to try to basically bootstrap a taxonomy if I can find one in the specific thing I'm looking for?
Yes, you can. So there is the sort of merging, but then you mean like merging the two tax? So you have an industry taxonomy. You would have to disambiguate those data sets. And again, going through that gap analysis and the coverage model approach, where you're finding the commonalities, the equivalencies within or between those taxonomies and the gaps, looking for the gaps, because you're going to want to account for the gaps. And the reason why I say that is that when you look at how industries are defined, there can be huge gaps in those definitions. I actually just modeled this. I think we chatted about it offline, but the gaps that you account for, you will find that some industries are modeled to be very high level and they align with the stock market. That's one good example of how the stock market, how we define an industry there. Others are defined alternatively by commerce. Those are very different views or different ways of modeling or structuring. Is one taxonomy, and this is just an example. IPTC, I think, calls it arts, media, and entertainment. That's the industry. Another taxonomy that I've been working with just calls it entertainment, right? And then yet another taxonomy, which is an industry taxonomy, has media and entertainment, right? So those are three parallels. But do you see how arts, media, and entertainment would be the highest level? And then the next level down, if you're combining the three, is media and entertainment. And then the child of that becomes entertainment.
Yeah.
I wasn't expecting the balloons, but yeah, it's something to
Me
celebrate.
neither.
So like you have to be able to iteratively account for those. And that's where clustering helps because often depending on the type of algorithm you're using, the clusters will appear with all three, arts, media, and entertainment. Those all cannot be the same level. Logically, it's not.
And when you mentioned to me you're a big fan of SCOS, especially,
Yes.
what makes it different to other ways of approaching building a taxonomy?
So other ways would be like in a spreadsheet and maybe representing it as OWL. That's the other schema I can imagine. Or you could use just primitives from JSON that's just parent-child type structuring. That's fine. But SCOS has a validation framework that will catch things such as recursive loops or self-referential data, which basically, obviously it's not ideal or optimal. We know that recursive loops are not great. And relationship clashes, that's the other thing. Relationship clashes are an issue within a system. So I like SCOS because it's supported by just a native intuitive validation framework, which is helpful. That helps to test how your taxonomy is going to behave with machines. That's really important. The other thing, it keeps you honest. in the structuring. You may not love it, but it's going to give you that feedback throughout as you model. It's the MVP, or minimally viable product, as far as ontologies go, because you're modeling with ontologies as soon as you initiate SCOS. It's W3C compliant, like that's pretty great. So you know that it's going to be machine readable as well based on the specs there. And the SCOS XL is the extension to SCOS that makes it compatible with OWL. So if you're wishing to get towards a knowledge graph, SCOS will model or will shape your taxonomy to be graph. So you've already started your work towards a knowledge graph naturally by doing that. So it makes it machine readable. It gets you closer to graph. It has the validation framework, and it's ISO compliant.
Yeah, I have two areas to go into. Let's start with one first, which is not really
Sure.
related. We mentioned Europe before, and I think in Europe one issue is like there are many languages that are actually spoken. Take a taxonomy and make it multilingual, because you cannot really translate the labels one to one, because it just won't
Right.
work.
You want to incorporate or integrate within your taxonomy like localization standards. So the same ISOs that you use for localization and globalization, you can apply and is compatible with SCOS. That's the other great thing about SCOS, is that you can include those multilingual labels and translation layer, as long as you line up with either the ISO for the 2-letter or 3-letter code. And I know Google Places is coming into purview, so you don't need an exact physical address, for example, when you get into like geolocation type work. But the idea is implementing those ISOs, the ISO specifically for globalization and localization language and country with your implementation of SCOS. So the two are symbiotic, and there's automatic, you can support automatic translation of the labels. Now, choosing what those labels are, I think that EU Voc has done a pretty good job of doing that, of incorporating it. It is tricky, but I've been successful in using SCOS and implementing the ISO for language and country.
Yeah. Now, if we disregard the like work volume, but focus only on how to get the best or highest quality taxonomy, would you actually build like, assuming we have like German and English, would you build the two taxonomies separately and then merge them? Or would you build one taxonomy and then translate it? What would be your
I
preferred
usually
approach?
do it. I usually do it as I go. So, for example, I'm about to start building a large taxonomy, and granted, I'm using top quadrant. So we have an enterprise semantic middleware that sort of has all this baked in. You have to select what you want baked in terms of your setting. But to your point, I'm building from SCOS. I have the ISO for language country, so that's done. And then automatically it translates the labels as I'm building. So that's the ideal, is that you're accounting for it while you're building. Now, with some instances and use cases, or depending on where you work or who you work for, that's required by another team. I'm thinking of Amazon, like when I worked at Amazon, or even here at Adobe, where I am right now, is you have a loc team, they're going to want to review and approve. And oftentimes finance and legal can be involved as well for approval of those labels. That's why, getting back to an earlier conversation, it can be dangerous to have AI or vectors completely create these classification schemes for you. Because oftentimes, for legal reasons, those localized, globalized, or translated labels have to go through some approval process. But if you line it up again with industry standards and rely on something like DBpedia to help to harvest those synonyms and primary labels, those systems have already been localized and globalized. You can download any language you want from any of those systems. Same with, if you want to work towards a thesaurus, you might use WordNet. Same is true there, or BabelNet. There's some beautiful knowledge graphs and work that has already happened in this space. It really depends on how much longitude and latitude you have for making executive decisions.
Yeah. And I think a lot of applications of taxonomies are like search related, whether that's tagging
Hmm.
or whether that's actually filtering out documents after the fact.
Yep.
What are some more of the creative ways you've seen that taxonomies are applied in industry?
Yeah. So this was an interesting one. Is at a former job, we had an author compensation model. It was a content-driven company. That author compensation model, they used the taxonomy with an algorithm that they built to be able to detect if the compensation patterns and results, so how much they were paying authors, was accurate. It turned out that they discovered that over 5 years, I think they would save over $8 million based on they had been overpaying authors. So they were able to use the taxonomy that I built in order to detect overpayment, and it had a huge impact on the bottom line. Oh, sorry, go ahead.
How did that
I
actually
said,
look like in practice? Like, how was the map between the taxonomy and the overpayment created?
Ah, so the nuances of it I can't really talk about, but I
Yeah.
will tell you that they use the taxonomy from a topical perspective. So once the content was tagged, the author related to that piece of content, because there were so many duplicate labels or near synonyms within the system, they were being overpaid because the payment had to do with the coverage of the content itself that the person had authored. And so when they eliminated or collapsed, because my taxonomy collapsed a lot of those labels, accounted for them as synonyms. Microsoft Azure is the same as Azure.
Yeah.
So someone was being paid twice for teaching a course on Microsoft Azure, right? So by just cleaning that portion up and having a realistic view or coverage model, they were able to refine and collapse the categories from which they were
Yeah.
paying. So that was helpful.
Yeah. So how it lives in my brain, basically based on the text, you could establish like a market size or an audience size for the
Yep,
given
yep,
author and the work,
exactly.
which you can then
Exactly.
take the compensation of.
That as well. Exactly. So that if they're royalties related, that's exactly it. That was the maturation of that exact framework was the royalty model. So there's a base compensation and then royalties. So that was like very interesting application of that. And it's a huge savings for an enterprise that's content driven. I think a lot of us know about the EU green taxonomy. That's a pretty interesting one. The green taxonomy enforcing a company's compliance on zero carbon and giving tax credits and kickbacks for complying or meeting the idea of greening your business. So that, and governments, for governments as well. And taxonomies are often used with cybersecurity or security systems, the NIST-NICE framework or taxonomy. That's an interesting application to catch bad actors. There was a really cool taxonomy, and I happened to get caught in it unknowingly. I didn't get my US tax refund a few years ago, and I called about it, and it turned out that they needed to verify my identity. I had to go through all these processes, and they were doing a beta test. The US government or US Treasury was doing a beta test with a new taxonomy to catch bad actors who were trying to get your tax refund by filing your taxes before I could. And so I happened to be caught up in this tax where the taxonomy was trying to capture bad actors. And the idea was to sequester users based on certain parameters that
Yeah.
would put them into this grouping. And it was because I had moved. I'd moved addresses 3 times in a couple years. I think that was the trigger. So taxonomies are very useful for catching bad actors in systems as well, and have been used for years in that way.
Yeah. That's really interesting. I think
Yeah.
I always tend to ask underappreciated and overrated. What technology, in your opinion, at the moment is underappreciated and overrated? And I think, especially on the overrated part, I'm really excited for your answer.
The overrated. I mean, if I say AI, I think that AI to a certain extent is like just how it's being marketed. Text to SQL. I know I'm going to sound like a sour person on this, but I see a lot of applications or implementations where we try to skip the necessary steps to structure data and we use these text to SQL, I think can be successful to a certain extent, but I haven't seen it scale well yet. I want to see it scale well, but I haven't seen it scale well because we're trying to impose structure like relational database rules in things like property graphs or AI, and we're trying to force something at this point that uh, force structure upon something that inherently doesn't have the necessary structure required for AI.
Yeah. To be honest, I think the term AI has completely lost its meaning
Oh, it has.
because even in the AI Act, like the definition they placed in the
Mm-hmm.
first draft, everything from an if-else conditions could have been AI. And
Yep.
I think in the hype cycle at the moment, we are way past expectations.
Way past expectations and lots of bets placed around it. And it feels like coming out of COVID, it was easy to grab onto this holy grail because the industry expanded so much that as it contracted, AI was like a soft landing in some ways and hopeful and promising. But the other thing is that with AI, we've abandoned these core principles of data management and think that, oh, we're like breaking free from these shackles and we don't have to do any of this anymore. We don't have to curate and care for our data. AI will just do it. And so I think that the negotiation with humans is part of the issue. And then also realizing the actual capacity of AI, like it's algorithms, like it's statistical reasoning. It's not human. We tend to look at it and expect it to be an oracle. Um,
Yeah.
and it's not that.
And on the other side, underappreciated, but I will force you to not say taxonomies.
Force me not to say taxonomies. I think something I'm turning to beyond, I would say knowledge graphs are gaining some appreciation, but ontologies. I do think ontologies are underappreciated. And that even though ontologies are required to create knowledge graphs, and that's a fact I'm sticking with, like ontologies can, there are lots of other applications for ontologies, such as structuring taxonomies. So can you have a taxonomy without an ontology? Sure. But how powerful and meaningful will that taxonomy be if it doesn't if it's not modeled using an ontology? I think that the pairing of the two, but also the application of ontologies to help to structure and govern taxonomies outside of a knowledge graph, just using the application of an ontology, is something that's not appreciated. We tend to want to skip to the next shiny, cool object, and that happens to be knowledge graphs. That's the other thing in the center of the tech radar alongside AI. And the truth is that you can't get to a knowledge graph without taxonomies and ontologies.
And if you could force one belief on every AI person in the world, what would it be?
I think how that although we want to give all the jobs to be done to machines, that we still need humans to shape the data, define the data, curate the data, because if we want to get the results we're expecting as the end result, then we have to have a hand in how we represent that data, period. So taking an out of the box taxonomy, for example, may be great, but you're going to find lots of gaps that you don't even know exist. And you're going to build up more tech debt than it's worth. So taking the time up front to really shape things properly is going to make a huge difference in your implementation and the results that follow.
Yeah. And if people want to follow along with you, hire you for building a taxonomy, or stay up to date with your upcoming book, where can they do that?
LinkedIn's really the best place right now. Lately, I actually have something upcoming, IA for AI, which is a conference that we're doing through Swarm Community, and that's October 10th and 11th. So I will be co-hosting that, and I have some pretty interesting interviews, including Kirk Cagle, who's amazing. You may have seen his articles around AI and structuring data. That's coming up. And then I'm going to be presenting and on a panel at Connected Data London in December, and then Data Day Texas. So I'll keep on posting here and there. I'm deep in build mode right now, which usually means that my brain's busy building and less on LinkedIn. But I'm happy to chat with anyone interested to hear any feedback or comments and continue conversations, because I think dialogue is where we really evolve a lot of these ideas and share across domains.
So what can we take away? I think, first of all, whether you like it or not, in some form of way, you're working with a kind of taxonomies or some kind of tags, whether that's in classification, in NLP or AI, whether that's in search with your tags and your filtering and doing query expansion. And I think her point that humans will always be needed to shape the data in some kind of way will hold true, or should hold true to a large extent, because we still have to give the models a boundary for the system in which they are working. And it's similar to what Joe Rice is doing with his whole data modeling, that you should spend a fair amount of time on the data model, on how the data looks, and this is very application dependent. And I think you should really try to target, like, whatever you're doing, like the classes, the different tags you're using, the taxonomy you're using, if you're so far, or the knowledge graph, is very application specific in the end. And there is probably no one who can really build it besides you, or besides the subject matter experts in your company. So you should probably spend quite some time first delineating what the different tags can be and how they relate to each other, and also how they in the end can relate to like business value in the end. I think that's a really interesting example with the authors that were overpaid just because they were classified in the wrong field, so basically which they were writing for, which in the end gave a wrong estimation of how large the target audience can be. And especially with LLMs at the moment, we see like how much impact it can have, how a field is labeled. And taking an out-of-the-box taxonomy, I would have never expected that it can have such an impact, but also that you should first investigate the purpose for which the taxonomy was created is also a good point. Like, the purpose determines in the end the application. So I'm working on a use case right now where we would need a taxonomy or ontology for industries, but we really can't find one yet. So we might have to create our own. So yeah, I think this was a really cool interview. I think I learned a lot. Especially I love to talk to people who are like in different fields and have very different perspectives. And I think there we can learn and probably transfer the most in our own field, because they have a very different way of thinking. And yeah, what Jessica is doing is really cool. She has a conference coming up soon, so go check her out, stay in touch with her. And otherwise, we will be continuing our series on embeddings next week, and I will see you soon.